Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 24, 2025, just yesterday. It introduces a deep research agent called Tulu-8B that uses reinforcement learning with evolving rubrics to train directly on long, open-ended research tasks, and it substantially outperforms existing open systems while matching or even beating some proprietary deep research tools at much lower cost. The paper is titled Tulu Reinforcement Learning with Evolving Rubrics for Deep Research. And as we will see later, the implications for training reliable long-form research agents are quite significant. Also, the author shared an official GitHub repo where you get the full Tulu stack, the agent library with tools and an interactive CLI demo, scripts to run benchmarks like Deep Research Bench and Health Bench, plus separate directories for supervised fine-tuning and RL training with evolving rubrics and reward models. On Hugging Face, you will find Tulu 8 billion parameter, SFT, and RL checkpoints, downloadable weights, plus examples for running the Doctor Agent Tool Use Framework and research benchmarks. Figure 1 shows that Tulu 8B delivers one of the best trade-offs between accuracy and price among deep research systems. In this scatter plot, higher placement means better benchmark score and movement to the left means lower cost per query. Tulu 8B sits in the top left band, which marks the Pareto frontier, meaning no other system is both cheaper and more accurate. Proprietary systems like OpenAI Deep Research and Gemini 3 Pro plus Search match its quality, but they cost far more per question. Figure 2 explains how the training setup turns raw web research into a graded, long-form answer. On the left, a user asks a complex question, and Tulu produces a multi-paragraph report with inline citation markers, which shows the style the model is aiming for. On the right, evolving rubrics score whole responses, while the policy repeatedly queries tools in the environment, so the evaluation criteria grow richer as the model explores more evidence. Figure 3 shows how evolving rubrics actually drive the reinforcement learning updates. The left side starts from a user query and some persistent rubrics, then the policy model interacts with web tools to produce several candidate rollouts, or full answers. The middle block contrasts those rollouts to generate new positive and negative rubrics that describe specific good or bad behaviors. The right side maintains a rubric buffer, which is a memory of the most useful rubrics, and uses rubric-based scoring to update the next version of the policy model. Table 1 shows that search-grounded rubrics are not only more specific, but also at least as factual as the other rubric types. An assertive rubric means the rule states concrete content that a good answer must include, rather than vague descriptions. General and closed book rubrics rarely give such concrete guidance, while the initial and evolving rubrics provide assertive, factual checks in about half of their criteria. Table 2 makes the core performance story very concrete. The reinforcement learning version of Tulu 8B clearly leads all open deep research systems on average across the 4 benchmarks. The table groups models into closed, naive retrieval, open, and fixed pipeline categories, so listeners can compare like with like. Among open models, Tulu 8B with evolving rubrics achieves the highest mean score, which shows that direct, long-form training really matters. Several proprietary systems still rank highly, but their margin over Tulu 8B is slim despite far larger size and cost. Table 6 makes clear that the kind of rubric used during reinforcement learning strongly affects deep research quality. Ablation here means systematically swapping out components, in this case, different rubric types, to see how each choice changes scores. Simple general rubrics slightly hurt average performance, while closed book rubrics give only tiny gains. Search-based rubrics consistently lift results across SQAV2, Health Bench, Research QA, and DRB. Adding evolving rubrics on top of search-based ones yields the best overall scores, with about 4 points average improvement over the supervised baseline. Alright, the big picture is that evolving, search-grounded rubrics let reinforcement learning directly reward good long-form research, which turns a modest 8 billion parameter model into a state-of-the-art deep research agent at tiny cost per query. This points toward widely accessible, trustworthy research assistance. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.